Hi everyone, my name is Hannah Earnshaw, my pronouns are they, them, and I'm here as part of the delegation from the Mars Ethical Settlement Alliance. If you were at James Gilley's talk yesterday, where he battled against Zoom to successfully introduce the organization, you'll know that we have a project called the Martian Papers, and this talk is basically the first Martian paper, I suppose, and the topic is defining Mars for the purposes of a Martian constitution. So one of our first projects was to write the preamble to a Martian constitution, and it begins with this line: "We, the Martians, declare Mars to be a free and independent state." And that's kind of the key value that we start off with. But a good question to ask at this point is, so what exactly do we mean by Mars? Now, I want to basically in this talk argue that we should mean not only the planet itself, but some associated regions of space which will combine form a Martian zone of sovereignty. And that would be a political definition of Mars for the purposes of this constitution. So start off with the obvious, the planet itself. I will come back to this because it's quite obvious. We want to include that in the definition. But basically, we're including the surface, the interior, and the atmosphere of Mars. But the next component that I want to add to the definition is its moons. And to understand why, I will go first to Earth's moon. Now, Earth's moon has immeasurable value to the people living on Earth throughout history. It's been a light in the darkness of night, a subject of religious devotion and myth, inspiration for song and story. It has physical effects on the Earth that people benefit from, be it the tides, the light at night again, and potentially also the stability of the Earth's wobble on its axis. Potentially the moon kind of helps regulate that as well. More recently, as we've been exploring and discovering more about the moon, we've then gained a wealth of scientific data, which tells us about the history of our planetary system and provides an inspirational story of exploration that then inspires further scientists to get involved down the line. So basically placing a value on what the moon is to Earth is, it would be a challenging prospect. It's pretty immeasurable. And these values will only expand over time as the moon becomes it becomes more used over time as we return to it, return people to it. It might take up a logistical function as well for missions going further into the solar system. Now, these benefits apply to people living on Earth. If people are living on Mars, they're not going to receive the same benefits from Earth's moon. They're going to probably receive similar benefits from the moons of Mars. So Mars has two moons, Phobos and Deimos. There's a bit of data about each one. And basically, Earth's moon will be distant and inaccessible to the people of Mars, but the sort of cultural and scientific and logistical benefits that people on Earth get from Earth's moon, people from Mars can get from the moons of Mars. So under the Outer Space Treaty of 1967, which I quote down here, no nation can claim sovereignty over the moon or over any other celestial body. And the reason for this is stated here, I quote from the first article, that the exploration and use of outer space, including the moon, shall be carried out for the benefit and in the interests of all countries, and shall be the province of all mankind, or of humanity. So it's clear that the benefits of the moon are intended to be enjoyed by everyone, and the taking away of those benefits by the actions of the state by trying to claim sovereignty over the moon won't be permitted under this treaty. However, implicit in this treaty and in the general position that the moon should be of benefit to all humanity is the assumption that all of humanity is located on or in orbit around the Earth. All states under the Outer Space Treaty are located on Earth, and all humans who have ever lived have done so within the Earth-Moon system, and thus have obtained benefits from the moon. We could even say that by banding together and sort of stating this about the moon, the collective Earth-based nations kind of assume a planet scale sovereignty over the moon. But for humans living on another planetary body, such as Mars, the benefits of the Earth-Moon system are inaccessible and inapplicable for the most part. Maybe science results can be shared, but otherwise, the benefit of the moon doesn't apply to them. And so, so this is, Earth is implicit here. And so the use of the Martian moons and sort of resources extracted from them and the logistical use and that kind of thing aren't necessarily guaranteed to benefit the people of Mars. For example, you could think up a hypothetical mission in which a spacecraft leaves Earth, lands on Phobos, collects some samples, does some science, and then returns to Earth to sell or do further research on these samples. And Mars, people living on Mars won't actually see any benefit from that unless they have the authority to set the terms of use of the Martian moons so that an equivalent benefit can be provided, such as by taxation or some kind of trade agreement or something like that. So in short, while it's not reasonable to expect Earth's moon to provide benefits to Martian residents, and it makes sense for kind of a planet scale sovereignty over the moon to belong to people on Earth, then Phobos and Deimos are primarily of benefit to the humans of Mars and not Earth. So sovereignty over the moons of Mars should then solely belong to the people of Mars in their entirety. Now, Phobos and Deimos are not the only objects in orbit around Mars. Mars has a gravitational well, and just as the moon is not the only thing in Earth orbit, the orbit of Mars has satellites in it. And the humans living on Mars will need satellites in the future. Our uses for satellites on Earth include communications, science, Earth observation, navigation, weather, all that kind of stuff. And people living on Mars will eventually need all these things too. We also use orbit for residence and research in the International Space Station and the Chinese space station Tiangong, and probably more space stations in the future. Now, given the nature of orbital trajectories for the most part, national sovereignty of airspace out to orbital altitudes isn't really a practical concept because satellites have no option but to pass over multiple countries over the course of an orbit. So agreements and organization with respect to the region of orbit are therefore global by necessity. Although largely still unregulated. One exception is the International Telecommunications Union, which governs the use of geosynchronous orbit around Earth. But otherwise, a billionaire can decide to launch thousands of tiny little satellites into space and encounter very little resistance to that. And so, you know, regulation is still pretty patchy. But such agreements about the use of Earth orbit are again implicitly Earth-based, since all affected parties are located on Earth, and the benefits of objects in orbit apply to the people on Earth. People living on Mars aren't going to get any benefit from GPS satellites around Earth, but they would from satellites in Martian orbit. So people living on Mars will need to be able to use the gravitational well of their own planet for their own purposes. So we'd want to add that to a political definition of Mars. In which case, how would we go about defining it? Well, here's where some physics can come into the matter. So we can start with a concept which is called the Hill sphere. Now, a Hill sphere is a spherical, mostly spherical region that's centered on Mars. And the Martian Hill sphere has about a radius of about 1 million kilometers. And that's a region in which the gravity of Mars dominates over the gravity of the sun. So anything within that region is going to fall towards Mars rather than falling towards the sun. And this is a region in which you are able to maintain orbits. We'd also want to include the Lagrangian points of the Mars-Sun system. Now, Lagrangian points are points in which if you put an object in that position, say you put an object here in L1, then it would stay in that location relative to Mars and the Sun as Mars orbits. So it will orbit basically at the same speed of Mars and always stay in that position relative to the Mars orbit because of the balance of the gravity of the Sun and Mars. Now, these are useful locations for scientific satellites. The Lagrangian points L1 and L2 of Earth are home to a whole load of satellites, 6 different missions as of 2021, with a whole load more planned for the future as well. And so we could foresee Mars also wanting use of these regions. Now, one thing to note about these regions is that they're gravitationally unstable. If you put an object at L1 and it kind of moved out a little bit, then it would end up falling towards Mars or the Sun. It's like a knife edge. So what satellites at these locations actually do, they orbit them in something called a halo orbit. And these halo orbits can be pretty large. They can be as large as hundreds of thousands of kilometers in radius. And so to kind of properly encompass the use of these spaces, we probably want to define something like this: a sphere of near Martian space, which would be 1.5 million kilometers in radius. Now, I need to give a quick disclaimer about this diagram, but it's not to scale. So this sphere is 1.5 million kilometers. The distance from Mars to the Sun is about 228 million kilometers. So this is a very distorted image to kind of zoom in on the space around Mars, but this is actually a very small fraction of the distance from Mars to the Sun, and indeed a very small fraction of the distance from Earth to Mars. At the closest approach, this is about 3% of the distance of Earth to Mars. So we're not encroaching on anyone else's space here. This is very much just around Mars itself. But the idea is then that this sphere of immediate near Martian space will then become part of the political definition of Mars, a bit like national airspace and territorial waters of nations on Earth. It's a region around this country that you need to kind of get in and out and you can make use of and derive benefit from. And so this region too then would also be under the sole sovereignty of the collective people of Mars. Now, as you can see from this diagram, the story is even bigger than that. So beyond Martian orbit, there are 3 other Lagrangian points, these balance points within the Sun-Mars system. So there's L3, which sits on the other side of the Sun from Mars. Now, we don't use L3 currently in the Earth-Sun system, but a number of uses have been proposed, such as a sunspot warning system, for example. And you could foresee having this having kind of security implications, given that if you put something at L3, you're basically hiding something behind the Sun from a planet. So in order to avoid any kind of nefarious shenanigans going on there, it's probably important for a planet to have awareness of its own L3 point and kind of jurisdiction over it. The other Lagrangian points are L4 and L5. Now, these are a bit different in that they're very stable. So objects that sit in these regions kind of tend to stay there, which means that, so they sit about 60 degrees ahead of and behind a planet respectively, and they tend to gather lots of dust and potentially asteroids as well, which we call Trojans. Now, the Earth-Sun system, I think, has 1 Trojan that we're aware of in L4 of the Earth-Sun system. Mars actually has 9 Trojans that we're aware of as of 2021, distributed between the 2 regions. And again, while we don't use these regions yet in our Earth-Sun system, there's still been sort of scientific missions that have flown by. There's more future scientific missions proposed to use them in the future, and they might have use for things like space stations as well. And as well as these points, there's plenty of use for the rest of just the Martian orbit in general as well. There are things called planet trailing orbits, which is a very fuel efficient way of keeping a satellite kind of close to a planet and sort of dropping behind year by year during the operation of the mission. So scientific satellites, Spitzer and Kepler, use that kind of an orbit. And then also ahead of the planet, there's things like the method of ballistic capture or low energy transfer, which is a very fuel efficient way of transporting materials to Mars from Earth without using the Hohmann transfer, which is useful, but it's bound by the fact that it has these very narrow launch windows. In the future, if you had non-time critical deliveries to make to Mars, then you might put an object basically ahead of Mars in its orbit and then let the planet catch up to it. And so that's then a use of kind of the orbital space ahead of Mars as well. So all taken together with the fact that then Mars and its associated Hill sphere is orbiting around the sun over the course of a year, it makes sense then to define a sort of a torus, a donut in shape, which would then be the complete Martian zone of sovereignty. So this would then basically be the width of the near Martian sphere, which is 1.5 million kilometers, as I described before. And then its radius would be the 228 million kilometers between Mars and the sun. This would be basically one big torus that would encompass the entirety of the Martian orbit and would include all celestial bodies within the region, including the planet Mars, its moons, and the Martian Trojans. And much like maritime boundaries or airspace over a terrestrial country on Earth, like this isn't to mean that things from Earth can't visit this space or use this space, but rather that the decision-making power over it, the authority over it, what this space is intended to benefit primarily is the people of Mars. And I mean, especially when it comes to things like scientific missions, it's quite likely that Earth is going to have better capabilities than Mars well into the future, and so would be encouraged to continue sending scientific missions out there. But rather it's to protect the long-term interests of a small and relatively less powerful Martian civilization that this zone of sovereignty then be set aside for them to grow into, and that it will be available for the people of Mars. So with that zone then defined, we can go back to the planet and then come back to the question of, well, okay, but why would we want to claim the entirety of the planet Mars for a Martian settlement? And why would we want to claim this like enormous region of space along with it? Wouldn't an initial settlement only require a very small region of Mars for its operation? And the reason for making such a bold move, I think, is because since all human nations in the past had existed solely on Earth, up until now, there hasn't really been a need to kind of codify sovereignty at a planetary level. But it doesn't mean that such sovereignty doesn't exist. As I argued in previous sections, that kind of sovereignty is implicit in the national and international governance of Earth, that any part of the planet can be lived upon, worked upon, preserved, laid claim to, or otherwise set aside for people not to lay claim to by people from Earth. And while the practical need to protect Earth territory from intrusion by external entities hasn't yet arisen, once there are viable human settlements outside of Earth, that will become necessary. So a first step for an initial Martian settlement must then be to lay claim to Mars for Martians. Now, all the initial population of Mars is all going to be coming from Earth in the beginning. So the goal of this claim wouldn't be to rule out other groups from arriving with the intention of becoming Martians themselves, but rather it will establish sovereignty over Mars and this whole Martian zone of sovereignty as belonging to those who live there, rather than to remote rule from Earth. So new settlements of people can arrive over time with the intention to live there, and then they could be incorporated into this planetary level of sovereignty as they arrive. So earning an equal stake in this entire Martian zone of sovereignty as part of their commitment to living fully on the red planet. They will entail the benefits of this region and also the responsibility for helping to manage it. Now, making a planet scale claim to sovereignty from the start will allow a more collaborative model of Martian land use to exist from the very beginning of human settlement. So rather than individual organizations laying claim to whatever they can as they arrive and operating completely independently of each other, decisions can then be taken collectively by the groups that arrive on Mars in light of the long-term good of the planet. So immediate joint responsibility for the entire Martian Zone of Sovereignty, it would not only be good for inter-settlement relations in the early stage of Martian habitation, but it would also be able to embed values such as environmental caretaking into Martian governance from the very beginning, which is a planet-scale responsibility that Earth is currently very ill-equipped to handle, given it's a whole load of kind of independent nations trying to come to an agreement. If we have a planetary scale governance from the start, then this will be made a lot easier. So I want to argue here that declaring this Martian Zone of Sovereignty that includes the entire planet Mars and this associated region of space to be under the joint sovereign rule of all political entities that are solely based on Mars is the best way to ensure then the long-term thriving of Martian civilization. Now, there's one other implication of this, which is quite interesting, is that I've made all these arguments for a Martian Zone of Sovereignty by kind of making reference to what Earth enjoys, but we don't actually have an official Earth Zone of Sovereignty at the moment. It's all implicit rather than explicit. But the formal establishment of such an Earth Zone of Sovereignty might be of clear benefit to the current residents of Earth as well. There are currently a whole load of groups that are calling for a more kind of united strengthening of Earth system governance as a whole, to address modern challenges such as climate change and other international scale issues. The problem of the use of orbit that I mentioned before is something that really needs to be handled on a planetary scale. And so hopefully by discussing the political needs of a future Martian civilization, we can also encourage the development of a full kind of Earth-Sun system governance as well. Basically, yeah, I just want to end by saying the human settlement of Mars will be a transformative event in the social and political landscape of humanity, and I think offers a real opportunity to start off on the right foot. And so starting from a planetary level at the beginning, I think is the way to ensure that the people of Mars can gain then the benefit of their entire system. So I'm going to leave that there, and some details for our Martian Papers project and a link to the Discord where we're discussing this stuff. And I'll take any questions.
All right, thank you. Any questions? Just go ahead and type them into chat. I'm assuming that the basic premise that you had for the torus and the L5 and all the Lagrange points would be the same for an Earth sovereignty zone?
Yeah, it would be. So the Earth Zone of Sovereignty would include the Earth Hill sphere, the Lagrange points. The torus would then, it would be, its minor radius would be larger because Earth is bigger than Mars, and so it would, there's sort of this larger orbital space, but then its orbit around the sun is kind of tighter, and so there's less space. It doesn't really matter, I think, the volumetric area of these things, but I did the math on it, and it turns out they're actually quite comparable sizes, which was kind of unexpected and amusing. But
oh, interesting. I would have thought the Earth one would have been much larger. But what would you say to those who think that the multiplicity of states is one of the great benefits of space settlements?
Yeah, I mean, I don't think that that this rules out a multiplicity of states. So the idea would be that as states arrive and kind of base themselves on Mars, they all get a stake in this planetary level governance, but as individual states, they're still able to govern themselves on a state level. I think it's important, though, to bake in cooperation from the start, and so that all these states will have a joint responsibility for the well-being of the planet and for the use of orbit, and for all of these kind of planet scale issues of governance that any one individual state can't really handle by themselves. So having that framework in place from the beginning, I think would be the best for the long-term prospects of then. I think it also has implications for encouraging cooperation between different settlements. Like, yeah, they might be independent, but being able to cooperate, to rely on each other to make these decisions about governance of the planet together will help establish positive relations between settlements, which I think will be needed, especially if Mars wants to kind of hold itself on an equal level to Earth. Cooperation and sort of strengthen numbers will be needed.
Yeah, that makes sense. Do we have any idea of how many asteroids are impact hazards currently to Mars?
To Mars? You know what? I don't know, and I'm not entirely sure anyone does know. I think it would be prudent, you know, in the relatively early stages of a Martian settlement to kind of establish the sort of similar kind of observation campaigns to Earth, which do look for asteroids and sort of try to find ones that might be an existential threat. I think I don't see it being an immediate concern, but like over time, I think Mars will develop a similar capability to Earth. And I guess the issue with asteroids is that they couldn't come from anywhere in the solar system. Like a lot of them come actually from the Trojans of Jupiter, for example. And so it's less about, I guess, sovereignty over space and more about sort of being able to respond to an incoming threat. But I think that's a kind of a separate topic. But I think, yeah, Mars should be able to do that. If there was an asteroid coming along and they had a plan of action to be able to act to divert that.
I guess at Mars, at least, so much of it's uninhabited, it would be less of an issue. Whereas,
yeah, it would be really bad luck for an asteroid to be like aimed at the sort of 1 or 2 Martian cities that, you know, begin at the start.
Right. Guess anything's possible. Do you have any ideas on how there would be dispute resolutions would be done between the various governments, you know, of these smaller settlements and the larger Martian government?
Yeah, I mean, I don't have a lot of concrete ideas, but I think we can learn a lot by looking at how kind of organizations such as the European Union or the United Nations, or even like, I guess maybe interstate conflict in the United States kind of work, kind of look to these examples and see how it's dealt with and kind of find a way of operating a sort of a planet scale governing body in a way that allows states the freedom to self-govern, but kind of has conflict resolution baked into it, and the kind of a forum to kind of negotiate and discuss things. I think definitely it's on the cards to examine these different kind of bodies and see how they handle conflict within them and find the best way of doing so on Mars.
Yeah, that makes sense. Well, that's all the time we have. It is time for the next session to start. So thank you very much for the presentation. And the recording of this session will go live in a couple of weeks after the conference has concluded. So thank you, Hannah, and hopefully we'll see everybody in the next session.